All right, hi folks, this is Larry Mussolino. I'm recording a video for MATH022, and I wanted to go over some topics in Objective 16. And so if you notice, Objective 16 is a mix of a few different concepts. We'll talk about union and intersection, solving an absolute value equation, and then talking a little more about linear inequalities as we did in Objective 15. All right, so let's get started. Let me come here to the first one, union and intersection of sets. Well, a set is really some elements put inside of curly braces. Let me give you an example of a set. I can have a set of, let's say, fruits. And the way I would list any fruits out is put them inside curly braces. So I could have grapes, apples, oranges. It would be up to me to list out whatever elements that I want. And notice we always put these elements inside curly braces separated by commas. Also, there's never any duplication in a set. So if I was writing a set, let's say the set A, it would be the numbers, let's say 1, 2, 3, 4, 5. I would never write the set A with a duplication like 3, 3, right? This is no good. We only write each element once. All right, well, let's come to this example. It says, find the union of these two sets. They're giving me a set H and a set G. They're asking me to find the union. Union means combine together all the elements in both sets. And we usually use a U symbol. So H union G, this U represents union. Well, what I'm going to do is just write out all of the elements in both sets combined together. It's kind of like putting everybody into the pool. 2, 3, 6, 7, 8. That was set H. Now I got to add in G, -1, 4, and 5. All right, that's the union. The intersection is listing out, intersection are the elements that are in common between the two sets. Well, in this case, for intersection, you use an upside down U as the symbol. Well, what I'm looking for now is I'm comparing sets H and D, looking for any elements in there that are in common. Well, notice there's really nothing in common between these two sets. So I'm going to leave it as just an empty set like that. So curly braces with nothing inside is the empty set. Sometimes we use this special symbol to mean the empty set. All right, let me do another example because I want to give you an example where there is an overlap or there is an intersection. So let's do another example. Let's say show another. All right, let's do this example. So let's do the intersection first. So they want the intersection of D and A. Remember, intersection, right, is an upside down U like this. Remember, those are the elements that are in common. So I'm going to compare these two sets. Well, the only thing I see in common is this number 3. That's the intersection. Let's do the union. The union means combine together all the elements. So I'm going to write 2, 3, 5. That's from set D. And then set A is going to be 0, comma. Now there's another 3 in set A, but I'm not going to write a 3 again because remember, you don't duplicate. So I'm just going to write 7 and 8. This would be the union. Okay. And roster form means listing out the elements like this. So we call this roster form, where you list out all the elements inside curly braces like that. All right, let's do another example of looking at intervals. All right, so what they want me to do is write out the union. So here's the union symbol. And here's the intersection symbol. But they want me to write this out using interval notation. Now, a good way to think about this is doing this graphically on the number line. So let me come here to the explanation so we can take a look at the number line. All right, let me graph the first inequality, which is y greater than 1. If you remember, when you have just a greater than symbol, you put an empty circle on the 1 and highlight all the numbers going to the right of 1. Let me also graph y less than or equal to 5. Well, I'm putting a filled in or a solid circle on the 5 and highlighting to the left. All right. Well, now let's find D union E. This is the union. Well, the way you find the union is you merge together the two graphs. It's almost like you're going to kind of write the two graphs together on the same number line. Well, if I combine the two graphs, I would have one graph going like this and the other graph going like this. But notice when I do that, I'm basically covering the entire number line, because this portion goes all the way to the left. This portion goes all the way to the right. So in essence, I've covered the entire number line. So the union is really going to be the entire number line in this example. Well, when you think, and this problem is going to ask you to write your answers in interval notation. Well, the way you write the entire number line is to say negative infinity to positive infinity with commas, with parentheses on each side like that. All right, let me scroll down a little bit. So here is the union, negative infinity to positive infinity. All right, now let's talk about the intersection, D intersection. What we're looking for here is only the overlap of the two graphs. That is, where do two graphs, where do they have a portion of the number line in common? Well, when I compare this graph with this graph, if you notice, the overlap is really this section right here, right? Those are the two. Imagine putting these two graphs like right on top of each other. Where are the two graphs superimposed or overlapping? Well, here's the answer then for the intersection. But we have to write this in interval notation. So I'm going to write it as 1, 5. If you remember, when you see a solid dot, you put a bracket. When you see an empty dot, you put a parenthesis. All right, so you have to really be on the lookout here for the difference between union and intersection. Union, you merge the graphs together. Intersection, you look for where are the graphs overlapping each other. All right, let's do another example. How about if we take a look at this kind of question? All right, now I'm noticing that they're using the word or in between these two inequalities. Now, when you see the word or, it's really the same as a union kind of question. If they had used the word and, that would be an intersection kind of question. All right, so our example really is going to be a union. Well, the way I can do this is solve each inequality, graph them on the number line, and then merge the two number lines together. So let's do that. I'm going to actually go to the explanation here. All right, well, you remember to solve inequalities, you're basically going to get x by itself on one side. So to get started here, I'm going to subtract 2 from both sides. Then I'm going to divide both sides by 4. So I'm getting x greater than -2. Well, here's the graph of x greater than -2. Let me solve the other inequality. I'm going to add 5 to both sides here. That's going to get me 3x is greater than or equal to -15. I'll divide both sides by 3. That gets me x is greater than or equal to -5. X greater than or equal to -5. All right, now I want to merge these together. So I'm going to merge these two graphs. Merge means, think of like putting them both on the same number line, and you're going to basically join these two graphs together. Well, if I do that, the result is going to look like this. So if I join these two graphs together, the result is going to be this graph. Because really, this graph here contains the top graph. So the answer here is this bottom graph, but they wanted the answer in interval notation. So when I look at this graph, it's starting at -5 and going all the way to the right, which is going to infinity. So it's -5, comma, infinity. Remember, for infinity, you always put a parenthesis. Because on the -5, I had a solid dot, that means I should use the square bracket. So the answer here is -5, comma, infinity. So for this problem, we solved the inequalities first. Then we graphed on the number line. Then we merged the two graphs together. The reason we merged them is because this was an OR question, and OR means union. Once we had the merged graph, we converted it to interval notation. All right, and folks, remember, please use these explanations for step-by-step guidance on these kinds of more complicated problems. All right, let's do an example of solving an absolute value equation. Now, when you solve an absolute value equation, what you're going to do is first, so let me list out the steps here. So here are the steps to solve an absolute value equation like this. First, you want to get the absolute value bars by themselves. I'll say get them isolated. So what I'm going to do to accomplish that is I'm going to subtract 5 from both sides of this equation. Because if I do that, I'm going to get just the absolute value of V on the right-hand side. Then what you do is you create two equations. Here are the two equations you create. Take whatever is inside the absolute value bar and set it equal to the number on the right-hand side. So V equals 7. Then create another equation where you take what's inside the absolute value bar, that's V, but set it equal to the negative of the number on the right-hand side. So I'm going to set it equal to -7. And these are the two solutions then. And if you think about it, it makes sense because if I have the absolute value of V equals 7, there's really two answers for V that would work. If V was equal to 7, I'd be taking the absolute value of 7, and that does equal 7. So that works. But what if V was -7? Well, if I take the absolute value of -7, I still get +7. So V equals -7 is a solution also. All right, well, let's do a little bit of a more complicated absolute value equation. All right, let's take a look at this one. Now, this one is one absolute value equal to another. All right, here's the way I'm going to solve this. I'm going to create two equations like we were just talking about. All right, the first equation is I'm going to take what's inside this bar and set it equal to what's inside that bar. And I'll come back and solve that equation in a second. The second equation is where I take what's inside this absolute value bar and set it equal to the negative of what's inside the other bar like that. All right, now I'm going to solve both of these equations. All right. Let me subtract 5w from both sides here. That cancels out, but that also cancels out. I'm ending up with -8 equals -7. That's a false equation. So really, this equation leads to no solution. Let me come over to the right-hand side, though. I'm going to distribute this negative sign inside the parenthesis. Remember, that means changing the sign of every quantity inside the parenthesis. All right, now I'm going to add 5w to both sides. That's going to get me 10w minus 8 equals 7. Now I'm going to add 8 to both sides. That means 10w equals 15. Finally, I'll divide both sides by 10 to get w by itself. W equals 15 over 10. I can simplify that fraction by dividing top and bottom by 5. So it looks like we're ending up with w equals 3/2. So this is the only solution. Now, in some cases, you could get two solutions out of this. In our example, though, the left-hand equation led us to no solution. But in a different example, I might get a valid solution out of that. All right, and folks, remember that there is this worked out example here that shows you how to set it up. All right, let me do a couple more. Let's do a couple of graphing of these inequalities. All right, here's what it wants me to do. It wants me to graph this inequality x less than 4. All right, well, here's the way you graph an inequality. So in this case, they want us to graph x less than 4. Step one is I'm going to graph the equation x equals 4. Now, I know this problem really is asking me to graph x less than 4, but the first step is going to ask us to graph the equation x equals 4. Well, if you remember, x equals 4 is going to be a line, a vertical line here at x equals 4. So this is the graph of x equals 4. Now, I have to make the line either a solid line or a dashed line. Now, if the inequality was a less than or equal to or greater than or equal to, I would be using a solid line. But if the inequality is a less than or greater than, I'm going to use a dashed line. Well, our inequality was a less than. That means I've got to make our line be a dashed line. So I'm going to make this be a dashed line. All right, now the last step is shade in one side of the line. I can either shade in the left side or the right side. Well, one thing I could do is just pick a test point to use. So I'm going to pick a test point. It could be any test point I want. I'm going to pick, I'm going to pick a point over here, let's say. This point is 2, 2. What I do is I check if this point satisfies the inequality. Well, the x value here is 2. The x value of 2 is less than 4. That's true. When the test point leads you to a true inequality, you shade in that side of the line containing the test point. If the test point leads you to a false inequality, then you shade in the other side of the line that doesn't contain the test point. So you could see the answer here is the blue shading is to the left of the vertical line at x equals 4. Now, when you go to graph this in ALEKS, you're going to see that there's a way for you to shade in one part of the line or the other. All right, let me show you another example of this worked out in an equation. Let's do this one. All right, here's an example that says graph this inequality, y less than or equal to negative 1/2 x minus 2. All right. Well, here's what we want to do to get started on this. Step 1. Graph the equation y equals negative 1/2 x minus 2. All right, well, I'm going to do that. One way I could graph this is use the slope-intercept form of a line. In our example, the slope is negative 1/2, and the y-intercept is negative 2. Remember, when you have the slope, the top number is the vertical change, and the bottom number is the horizontal change. Now, what I'm going to do here is I'm going to rewrite the slope to put the negative sign on top with the 1. That makes it a little easier to work with. So I'm going to make this negative 1/2. Well, if you remember, the top number is the vertical distance to go, and the bottom number is the horizontal. So what this is telling me is go down 1, and then go over to the right 2. All right, so let me go ahead and do this. I'm going to put the y-intercept here at negative 2. Now I'm going to use a slope to get the next point. I'm going to draw it a little bigger because it's a little small on that graph. Let me draw it like this. Here is negative 2. So I'm going to put the y-intercept there. All right, now I want to go down 1 and then go over to the right 2. So I'm going to go down 1. Then I'm going to move over to the right 2 and put another dot. Here's that blue dot. I'm going to connect these two with a straight line. There it is. All right, so we graphed the line. That was step 1. Step 2 is make the line either a solid line or a dashed line. Remember, if the inequality is a less than or equal to or greater than or equal to, use a solid line. If the inequality was less than or greater than, use a dashed line. Well, our inequality is less than or equal to, so we want to use a solid line. So notice here's a solid line. And when you go to Graph and Alex, you're going to see that there's a way for you to change the graph, the line itself to either be a solid line or a dashed line. All right, so we have that step 2. Let's go to the last step. The last step is to shade in one side of the line. So I want to shade in step 3. Shade in one side of the line. Well, should I shade in above our solid line or below the solid line? Well, I'm not sure, but here's what you do. You end up picking a test point anywhere you want. So I'm going to pick a test point. I'm going to pick, and this is totally up to you. I'm going to pick, I'm going to come over here and pick 6,2 as my test point. All right, so my test point is 6,2. What I do is I go to the starting inequality and I plug in this XY values into my inequality. I want to see if this inequality is true or false. All right, so the Y value is 2. The X value is 6. All right, let me work this out. Here I have 6 divided by 2, which is 3. So that's going to be negative 3, subtract 2. 2 is less than or equal to negative 5. Well, that's false. Right? 2 is greater than or equal to negative 5. So it's a false inequality. Here's our test point. When the inequality is false, it's telling you to shade in the other side of the line that doesn't contain the test point. That means we want to shade in this bottom part of the line. Remember, if this inequality had been true, I'd be shading in the side of the line that contained the test point. But in our example, the inequality turned out to be false, which is why I'm shading in the other side of the line. Okay, so let me scroll down just so you could see the final answer here. Again, you could see how in this graph, they're shading in the bottom of the line. Okay. All right, folks, hope this is helpful as you're working in Objective 16. Please let me know if you have any questions.